Good morning. Today I would like us to continue with the question that somebody sent to me privately. He said he needed a detailed explanation on how to solve this type of question. And what we are going to do is because we know we are in revisions section. What we are going to do is this: we are going to use this question to summarize electricity. In other words, most of the information I'm going to give, although we'll be answering the question, but much of the information I'm going to give will try to have an holistic view on electricity. And the very first thing which we are asked to do here is this: we are asked to state Coulomb's law. We are asked to state, Ohm's law. And when we are stating the Ohm's law, you remember that Ohm's law is talking about the relationship between the potential difference and current. So we say that the potential difference between the two ends of a conductor is directly proportional to current. Potential difference between the two ends of a conductor is directly proportional to the current, provided that the temperature is constant. And under here, let's just get some facts which you need from this equation. That potential difference between the two ends of a conductor is directly proportional to the current, provided that the temperature is constant. We should remember that temperature is constant because we don't want to change the resistance, because in some materials, increase in temperature will lead to increase in resistance. So that's why we are making the temperature to be constant. And remember that phrase, include it anytime we're asked to define Ohm's law. And one thing we're supposed to know in Ohm's law, remember, we said V is equals to IR. I want to talk about a common error that is often listed in the diagnostic report. You see, this is the voltage, the current, the resistance. The most thing we should try to avoid is this: we must make sure we do the right substitution. In other words, if I'm using a voltage, for example, look at it here. They say V. There's V here, which is the EMF. There's another V, which is the 20 volt, which is the external volt. There is also V here. So we must make sure that the voltage we are using, whichever voltage I use here, that this current must be that, and I also substitute my resistance. The current must be the current that is flowing through this R. And this voltage must be the voltage across this R. You must not mix them up, because that is the common mistake we normally say. The resistor you are thinking of here, whichever resistor you write here, this current, this I must be the current that is flowing through that very resistor. And the voltage, the potential difference you have chosen must be the voltage across this. Not just choosing any voltage and any resistance we have in this question. That is a common mistake we normally see. And I hope I will also use this question to explain it to us very well so that we understand it. Let's go to the second one. Let's go to the second question, which asks us to define the internal resistance. we're asked to define the internal resistance. Internal resistance is the resistance found inside the battery due to the movement of charges. Due to the movement of charges inside the resistance, it is the resistance that is found inside the battery due to the movement of charges inside the battery. And one thing we need to know here is this, that this, remember, when we write this equation, remember when we say that EMF is the addition of the V external or the V load plus the V lost. Remember that this V lost is as a result of the internal resistance of the battery. In grade 11, we make it to be 0 because we want to simplify it at that stage. But now we are introducing it in grade 12. So always remember, this is the V lost. And this V lost is as a result of the internal resistance of the battery. Always remember that internal resistance is always there. And let's move ahead with the question here. The next question, we are asked to, okay, we are told that the S2 is now closed. No, number three, say what is the reading on the, what is the voltmeter reading when the S1 is closed? When this, no, it's open. When this is S1 is open, yes. When the S1 is open, they say what will be the reading of this? And if you look at it here, this one is obvious because once you look at it here, and let's get something here. It say what is? What is? The question didn't ask us calculate, because sometimes you see a learner trying to calculate. When you are asked what is or determine, they say what is the voltmeter reading when the S1 is open. So we don't expect to calculate when anytime they say what is or determine. So look at it here. They say S1 is open, and when S1 is open, what is happening to this battery? You can see that this is a major switch here. You can see that it's not a complete circuit anymore. And when it's not a complete circuit anymore, you see that this battery will not be delivering current to an external circuit. And you see the V1 here is connected to the battery. And remember how the electromotive force, the EMF, is the voltmeter reading when the battery is not delivering current to external circuit. Remember, we don't define it that way. Don't define it that way. So in this very case, we are just asked what is it going to be. It will give us the reading of the EMF. Let's remember the unit. I cannot overemphasize this at this stage, 24 volts. So in other words, they are asking us the value of the electromotive force, the EMF, in an indirect way. And that is exactly what we have here, because they say S1 is open. So when the S1 is open, the battery is not delivering current to an external circuit. So the reading of this V1 is going to be 24, which represent the EMF of this battery, which will give us the EMF of that battery. Let's continue with the next one. Don't mind my printing here. My printing wasn't clear because I printed this as a picture, but the question is posted on the group. Is clear on the group. I've posted the question on the group. Then the next one is 4,1. We are told from this question, we are told that S1 is now closed. We are told that S1 is closed. And remember from the question, if you read the question very well, we are told that when S1 is closed, the value of this changes from 24 to 20 volt. That is a very vital information. The value changes from 24 to 20. The reading of the V1, it changes when the S1 is closed. Okay, let's see now. So what are we asked to calculate? We are asked to calculate the reading on A2. Okay, if we are calculating the reading on A2, if you are calculating the reading on O2, in other words, the ammeter, remember that the ammeters, they are always connected in series. The ammeters, they are always connected in series. And normally when ammeters are connected in series, remember they have a very low resistance. And the voltmeter, they have a very high resistance, and they are usually connected in parallel. Voltmeter, they are usually connected in parallel. They have a very high resistance, and the ammeter, they have a very low resistance. They are always connected in series. So now we ask, what will be the reading of this one be? Now let's go through the table. Let's go through that diagrams. I want us to analyze the diagram very well so that we should be able to answer this question effectively. From this question, I have A1. This one is A1. The current, when the current flows, you will see that the current that will be passing here will be the total current, because it's connected. There's no branches here. This will be the total current. The total current will be passing through A1. And when it gets here, also the total current will also be passing here. But by the time it gets here, you will see that some of the current will pass here and some will pass here, because there is a branch there. Because there is a branch there, you can see, remember, the current comes, the conventional current. The conventional current, it flow from here, move through here. Remember, conventional current from the positive to the negative. So the total current will flow through here, the total current will flow through here, but I don't know what that total current is. And this is the very first thing you have to do when you are given a question. When you are given a diagram, before you even go to the question, make sure you analyze the diagram very well and understand what the information the diagram is giving you. And that is exactly what I'm doing. If you look at it here, the total current will pass here, the total current will pass here, although I don't know what it is. But by the time you get here, you will see that that current will divide. Some of them will be the I2, which we are trying to solve, and some of them will also pass here. Let's call this one, for convenience sake, let's call this one I3. Let's call that one I3. So you will see the I2, they will pass through here. The I2, the current passing here will be I2. The current passing here will be I2, which will go through here and a link. Remember, they say this one is now closed. It will now link. And this one I3, by the time they get here, you also have the I total. And remember, the internal resistance, the current passing through it, is also what? I total. So we should know, you can see you have a lot of current here, and this is the common mistake we normally use when you are using this formula, because there are many currents here. You have I2, you have I3, you have I total. So anytime you are using this simple equation, this equation is very, very simple to write. Most learners can write it, but most learners cannot use it. So if you look at it here, you will see whichever resistor I'm using. If I'm using 4, for example, I must use the current I2. If I'm using this 4, I must use the I2. But if I'm using 16, I must use I3. They are not the same. If I'm using this R, I must use the I total. If you understand this, you will be able to solve electricity question anytime, clearly at any time. Because this is because sometimes I tell people this is one of the easiest questions you can get in matric exam, if you really analyze it very well. And you can see the way I'm analyzing it there, because I don't want confusion. I don't want confusion. If I get an answer, I'll come and put the answer here, because this is my mind map. It guides me on which area to go, so that I will not forget whichever answer which I've gotten previously. So now let's go to the question proper. You say the reading on A2. If you look at the reading on A2, look at it here. You say, what is the reading here? This one is 4, and this 4, these two 4, they are in series. 4 ohms and 4 ohms, they are in series. Why? Because the same I2 is flowing through them. But if you look at 16 and this 8, the addition of these two, 16 and 8 here, you can see they are in parallel because different current is flowing through them. This one is I3, this one is I2. Different current are flowing through, so they are in parallel. But 4 and 4, they are in series because the same current is flowing through them. Let's bear that in mind. And here we are given this value. We are given this value from the question. We are giving it to be 4 volts. And remember, anytime you are given this equation, once you are given two values, you can get the third one. So you can see, I cannot use this one because here, I don't know the voltage across this one. I don't know the voltage. Also here, I don't know the voltage across this one. So the only resistor which I'm giving two values, the only resistor which I'm giving two values is this. So in other words, that attracts me here because I wasn't given the current here. I wasn't given the resistance here. So the only place where I was given two informations is here, and that is exactly where I'm starting. And that is what you look out for in examination. Where are you giving more information? You are giving one information here, which is 4, 16. But here I'm giving 4 and 4. 4 volt and 4 ohms. So I can easily calculate the third one. So here I'm asked to calculate the current, and it's always very important. It's always very important to say V is equals to IR. I advise my learners, I say, write the formula like this, whichever one you're asked to calculate. Because I've noticed some will like to make the subject of formula. At the end of the day, they mix up the equation. So always write the equation here, then you substitute. If you write a correct equation, substitution, you get the mark for substitution. So here, I'm applying the Ohm's law. I'm applying it here. So whatever I'm using will be at this 4 ohm resistor. Whatever I'm using will be here. I will not go and pick 20 or 24 or what else. I'm applying Ohm's law on these 4 resistors. So here I have I2. This my I is I2. I don't know what it is. Times 4. I'm applying it on this 4. What is the voltmeter across this 4? Is 4 volts. So if you do that, you can see that our I2 are divided both side by 4. I will get my I2 to be 1. I will get my I2 to be 1. And once I've gotten the I2 to be 1, I will take note of that. I will take note of that. If I'm working on the exam condition, I will now say, okay, my I2 is now 1. My I2 is 1. Because that diagram will guide me. It will be my mind map. It will guide me as to what, because I've calculated this one is now 1. In other words, I know the current that is now flowing on this branch of the parallel circuit. On this branch is 1. Let's go back to the other question. They say the reading on A1. Okay, now they want the current for the total one. We want the total current. So let's see. Let's see. They are looking for the total current. If I'm looking for the total current, which is, they say 4,2. Remember we said that the total current must be the addition of, I put this one I3 plus I2 because it's the total current that divides into this. Okay, I say, how would I get the total current? I don't know I3. I don't know what it is, but I know I2 to be 1. And I don't know the I total. Now there's a question, there's a problem here. You can see I have two unknowns. And when you have two unknowns, it's telling you that there's next step which you can use to calculate